Hey guys, so we're going to be starting part 3 of the SHSAT math review for the 2019 to 2020 test. So let's get started. So we're on question 74. So we know that m times t is equal to 72, and we're being asked for the sum of the values of m when t is equal to 1, t is equal to 2, and t is equal to 3. So basically the approach that I'm going to take for this problem is I'm going to solve for m for each case, and then I'm just going to sum the values together, right? So when t is equal to 1, I have m times 1 is 72, so m would just be 72, right? And then when t is equal to 2, I have m times 2 is equal to 72, so m is going to be 36. And then finally, when t is equal to 3, I have m times 3 is 72, and then m would just be, so 72 divided by 3 is going to be 24, right? So we're just going to add 24 plus 36 plus 72, and that would give us, let's see, it's going to be 60 plus 72, which is just 132. So that would be G. Okay. And then we're going to go to question 75. Okay. So we have a diagram showing a rectangle with a inscribed triangle. So this is this white triangle, that's our inscribed triangle. And we know that the triangle's vertex and base touch the sides of the rectangle, right? So this is the vertex of the triangle, or one of the vertices, and this is the base. And so the total area of the shaded portion, that's like this portion right here and this portion. So in order to get that shaded portion area, we can take the area of the rectangle. So take the area of the rectangle and subtract the area of the triangle, right? Because basically that subtraction is going to yield everything that's in the rectangle except for the triangle, which is the shaded area. So the area of the rectangle would be just its length times its width, right? So 8 times 16, right? This times this. And then the area of the triangle is going to be its base times its height, right? And the height of the triangle is just going to be 16, right? Because it touches both sides of the rectangle. So that's 16. And then it's base times height over 2. So this would be our subtraction that we're going to do. And so I'll do the work here, right? So we have 8 times 16 minus... so 4 divided by 2 is 2, right? So 2 times 16. So this would just be 6 times 16. You can just like do the math, but anyway, that's 6 times 16, which is 96 square feet. So that would be C. Okay. So now we're going to move on to 76. So we know that orange juice costs $2 per gallon, and grapefruit costs $3 per gallon. And a recent shipment of equal amounts of the two types of juice costs $2.50, right? So we can put this as an equation, right? So we have X amount of orange juice costing $2 per gallon. So this is the cost of orange juice. And then X amount of grapefruit juice costing $3 per gallon, right? Because we're being told that we have an equal amount of the two types of juice. So we assume that that equal amount is just X amount, and then we're multiplying it by the price of these things per gallon, right? So we have X gallons of orange juice, and then $2 per gallon of orange juice, right? That's the price. So that's why our equation makes sense. And we know that the total cost of both of these juices is going to be $250. So we're being asked to solve for how many gallons of orange juice in the shipment, right? So we said that X is both the number of gallons of orange juice and the number of gallons of grapefruit juice because they're equal. So we just need to solve for x. So that would be 50. Okay. Okay, so if we move on to 77, so we're being told that, here, let me shift it over a bit. 5 consecutive numbers have a sum of 110, and we want to know what the least of these consecutive numbers are. So if 5 consecutive numbers have a sum of 110, what I'm going to do is I'm going to say that the middle number is x, right? So then there are going to be two numbers greater, x plus 1 and x plus 2, and then two numbers less, x minus 1 and x minus 2, right? So those are 5 consecutive numbers. And the reason why I did it like this, where I minus 2, minus 1, plus 2, is that if we want to add all of these numbers together, right, because we're told that the sum of these numbers is 110. So we're going to add these numbers together and set it equal to 110, and then solve for x. So if I add these numbers together, I have x minus 2, and right, I'm just going to change the order that we add it, right? So x minus 2 I'm going to add with x plus 2, and then x minus 1 is added with x plus 1, and then finally we have to add x, right? So the sum of all of these is 110, and we can see in each case that the minus cancels out with the plus, right? So they're paired very nicely like that. So this is basically just 5x. So this is 5x is equal to 110. And that would just be x is 22, right? So that's the middle number. So that's this thing right here is going to be 22. But we're being asked for the least of these numbers. So the least of them is going to be this x minus 2 right here. So that would be 22 minus 2, which is just 20, right? So 2 less than this middle number. So that would be C. Okay. So now we're going to go on to 78. So we know we have these like expressions right here. And we're being told that m and n are both positive integers. So we want to know how many of the 5 expressions above are equivalent to mn. So if we look at like this one right here, we can sort of see that this is clearly not equivalent. Or I guess one of the things we can do, I mean, we could do this, like we could reason through this, but it might be easier to plug in values. So I'm going to say that m is going to be 3 and n is 2, right? So if we look at minus mn, that's going to be minus 3 times 2, and this is negative 6, right? We're being asked if it's equivalent to mn. So mm is just 3 times 2, which is 6, right? So this 6 value, this is the value we need to check against. So since negative 6 is not equal to 6, we know negative mn is not equal to mn, or equivalent to mn, right? So now let's look at the next expression, right? So we have negative m times negative n. So if we plug in values here, that's negative 3 times negative 2, which is 6, and 6 is equal to 6, right? This is our reference. So therefore, this second expression is equivalent, so I'll put a check mark. And then we'll look at this one, the absolute value, right? So we're plugging in 3 for m and 2 for n. So this is just the absolute value of 6, which is equal to 6. So that's what we want, right? And then negative mn, so this one. So this would be negative 3 times 2, which is the absolute value of negative 6, which is still 6. So this also works. And then finally this one, it's going to be negative 3 times negative 2, right? So this is just the absolute value of 6, which is 6. So that also works. So basically we found that all of these expressions, so all of them except the top one, are equivalent to mn. So that's 4 expressions. So that would be h. Okay. So now 79. We have this expression and we basically want to simplify it. So first I'm going to look at the numerator, right? So I have two things with the same base and different exponents multiplied together. So I can use my, here I'm going to erase some of this stuff. I can use my exponent rules, and I know that when I multiply two things with the same base, I keep the base and then I just add the exponents together. So this is like this, and then this is 5 to the 10th over 5 squared, right? And then when I divide two things like this with the same base, I can just keep the base, subtract the exponents. So this would be 5 over 8. So that would be our answer. That would be A. Okay. And I will continue with the next video, so part 4 on question 80. All right, see you then.